So this is a hyperbola because it's a subtraction in between the two. It would be an ellipse if it was plus in between the two. So a hyperbola looks something like this, as you probably know. What we're looking for in this question are the asymptotes. So these are diagonal asymptotes where the hyperbola gets infinitely close to but never touches. So that line I just drew is a slant asymptote is what they call it. And then here we got another slant asymptote, if I can draw it right. And that's a straight line, that's another slant asymptote. Okay. So there's a quick little equation for both of those. Hyperbola has subtraction, so order matters. If x comes first, this is the equation of the hyperbola of the asymptote, and if y comes first, these are the equations. Okay? So remember how it goes for h and k. Sorry, instead of drawing it out, I just copied and pasted it here. H is always the number subtracting from x. K is always the number subtracting from y. So even if y came first, if it was y subtracted by x in the equation, it's still h is always paired up with the x value. And so the equation of ours, it's x is coming first in the hyperbola. We need y equals k, so that's a -4 because the formula says minus is built into it, so we need a -4, and that's plus or minus b. In this case, b is 15. Need to double check. Yeah, there we go. Okay, it's always some number squared, so that's 15 for b, and then 1,296. I don't know what that is, so let's take the square root of 1,296. That's 36 for a. X minus our h is also a -4. So there's your two equations. You've got y equals -4 plus 15 over 36, x plus 4, that's one of them, and y equals -4 minus 15 over 36, x plus 4. You could rearrange and simplify if you want, but I think it's okay to type it in like that for noon.